Today we're going to talk about parallel and perpendicular lines. Parallel lines are lines that never touch each other at all, and their symbol is indicated by two vertical lines. Perpendicular lines are lines that intersect each other, which means to cross, but not just crossing. They have to cross at exactly a 90-degree angle. And the symbol representing perpendicular lines, it looks like an upside down capital T. So we've seen parallel and perpendicular lines in the real world, but mathematically, what makes parallel and perpendicular lines? Let's talk about it. Parallel lines have the same slope. Perpendicular lines have the opposite reciprocal slope. Now, we've talked about how slopes will transform a line and the steepness will change from either really steep or it's not very steep. So slope is how the line changes. So you can see why slope is important for parallel and perpendicular lines, because it's all about how they're positioned. So what do I mean by opposite reciprocal? All right, let's discuss and let's think back what opposite is. If I gave you the number of 3, the opposite of 3 would be -3. If I gave you the number of -1/2, the opposite of -1/2 is a +1/2. So when we're talking about opposite, we're referring to the signs. Well, let's talk about reciprocal. What if I had given you the number 1/3? What would be the reciprocal? The reciprocal would be 3/1. Or let's do maybe the number 4. What would be the reciprocal for the number 4? It would be 1/4. Because remember, if you're going to make any whole number into a fraction, there's always a number underneath it as 1. And we've dealt with this rise over run in reference to slope. So reciprocal means somewhat of the flipping of what's there. Opposite has to do with the signs, and reciprocal has to do with flipping. All right, let's get going. If given equations, how do you determine if lines are parallel and perpendicular? If we were given the picture, you guys would be excellent at that. So how do we determine it if we're given equations? This is how. Find the slope. Remember, that's what's important. Find the slope for each equation and compare them based on the criteria that was up above, that parallel lines have the same slope and perpendicular lines are opposite reciprocal slopes for each other. So let's take these two equations down here. Determine if the following lines are parallel, perpendicular, or neither. So we have y equals 1/2 x minus 1, and we have 4x plus 2y equals 6. So determining if they are parallel, perpendicular, we have to find the slope. Well, let's look at the first equation. Do we know the slope already? Yes, we do. The slope is 1/2, and it was easy to pick that out because this equation was written in slope-intercept form. What form is this equation written in? If you said standard, you were exactly right. So it's hard to depict what slope is from standard. So let's do this. Let's transform this and put it into slope-intercept form, which is y equals mx plus b. So here we go. Trying to get y by itself, I'm going to move the 4x term to the other side by doing the opposite. So on the left, I have 2y equals -4x plus 6. Now, still y is not by itself, so let's keep going. I'm going to divide everything by 2. Clean that up. 2 divided by 2 is 1, and that's what we want. -4 divided by 2 is -2x, and 6 divided by 2 is 3. So now we are in slope-intercept form, which is easy to find where the slope actually is. So we've got -2. Okay, so in this first one, we had 1/2. In the second equation, we had -2. Is there any relationship between the two? Well, we know that parallel lines are supposed to have the same slope, so we can cross out parallel right now because those slopes are not the same. Let's go for perpendicular. Perpendicular says they have to be the opposite sign. This one is positive, this one is negative. Okay, so we're halfway there. And then it says it has to be the reciprocal. So let's see, 1/2, then it's flipped, 2/1. So we've got both criteria met for perpendicular. We can establish that these two equations, if we graph them, they would end up being perpendicular lines because the slopes are opposite reciprocals. Now notice I had neither down here because every line in the world is not parallel and perpendicular. There are some lines that are they just cross each other. So if there's no relationship, then it could be neither. They're just regular old lines. So what if I wanted something like this? Write an equation of a line that contains the point -2, 3 and is parallel to y equals -5x minus 4. So I'm getting real specific with you now. Okay, we know we want the equation to be parallel, and we know we want it to go through this point. And it has to be parallel to this one here. So if it has to be parallel to this one, this is the equation that it's being compared to. Let's find the slope of this line first. Now, lucky for us, it's given in slope-intercept form. So their slope is -5. All right, okay, so we found their slope, but we want ours parallel. So what is our slope going to be? Okay, so their slope is -5. And our parallel slope is going to be, you're right, -5. The reason we know it's going to be the same thing is because that's the definition of parallel lines. The slopes have to be the same. Okay, so this is what we're going to use right here, ours. But now we want it to go through a point of -2, 3. It has to go through that point. What information do we have? And which form can we go in? Meaning standard, slope-intercept, point slope, all of that stuff that we've talked about before. Let's use it right now. What form can we go into? Yes, we need to go into point slope. That is what we have. We have a particular point the line has to go through, and we know what the slope of the line is going to be. So let's go. Y minus the y coordinate, which is 3, equals our parallel slope, which is -5. Open parentheses. X minus the x coordinate, which is -2. I'm going to go ahead and clean that up and make it +2. All right, so then from here, let's clean this up and let's solve it for y. So let's do the distributive property. So y minus 3 equals -5x minus 10. And I'm going to add 3 to the other side. And I get y equals -5x minus 7. Check. This is the equation of a line that is parallel to the one that was given. Parallel slopes mean the same. Let's go for perpendicular then. All right, writing a line, or write an equation of a line that contains the point 6, 2 and is perpendicular to y equals 2x plus 7. Okay, good deal. Perpendicular. New form here. Perpendicular slopes are opposite reciprocals. That's important. We can't just use any slope that we want. It has to be the opposite reciprocal of what's given. So let's find their slope. Their slope is 2. Their slope is 2. What is our perpendicular slope going to be? We want ours to be perpendicular. So our perpendicular slope has to be the opposite. So the opposite of 2 is negative, or opposite of positive is negative. And the reciprocal of 2, remember this is like 2/1. So the reciprocal of 2 is 1/2. This is our perpendicular slope that we will use, a -1/2. Now, sometimes slope's not going to be given in slope-intercept form. You may have standard form right here. You may have a point slope right here. You have to transform it so that you can find the slope. All right, let's keep going. So we know we want it perpendicular to that one, but we want it to also go through this point of 6, 2. Which form are we going to go into now? You got it. Point slope. Let's go. Y minus the y coordinate, which is 2, equals our perpendicular slope goes right here, which is a -1/2. We have to use ours. This is the problem we're working out. Open parentheses, x minus 6. All right, equation of a line we know is represented in slope-intercept form. So let's clean this up here. Distributive property first. Y minus 2 equals -1/2 x. 1/2 times 6 is 3. Negative and negative is positive, so I've got a +3 right there. And I'm going to add 2 to the other side. Y equals -1/2 x plus 5. We are done. This is the perpendicular line to the one that was given. Now notice we put them in slope-intercept form. Your directions could say, put this in standard form. It could say leave it in point slope. So make sure that you're reading directions. So let's sum this all up and let's write some steps. Steps on solving this, if you wanted to put it in that order. Step 1, find their slope. Step 2, determine what your slope is going to be. First is theirs, and then determine what your slope is going to be based upon if it is going to be parallel or perpendicular. That's important. Step 3, put your information into point slope form. Step 4, clean into the form according to the direction, slope intercept, standard, point slope, etc. So we will see you in class.